My name is Corey Warren, and this is our presentation on climate change and the overview of it. We're going to start off with air currents. Air currents is the movement of air in the Earth's atmosphere. And within these currents, warm air rises into the atmosphere and cold air sinks down below into the Earth's surface. With this movement, it creates air circulation patterns around the Earth. Air currents move heat and moisture through the atmosphere, which impacts Earth's climate. And with, as we stated in the previous slide, air circulation, it can help create rainforests. It do this by taking warm, moist air that rises near the equator and cools it, and with that, it produces heavy rainfall. And that's how you create rainforests. And after that, after losing moisture, the dry air moves away from the equator, and that's how it creates dry areas and deserts around 30 degrees latitude. Also within air circulation, moves moist air and clouds around the planet, which also influences climate and weather around the world.
Ocean currents. What are mine? Ocean currents are large, continuous movements of seawater that flows through the world's oceans like giant rivers. There are two types of ocean currents. There are surface currents and there are deep ocean currents. Surface currents occur in the upper 400 meters of the ocean. They are driven mostly by wind. They move fast, up to several miles per hour. The deep ocean currents, they move slowly through the deep ocean. They are driven by densities, differences of temperature and saltiness, and they're part of the global conveyor belt. There are four causes to ocean currents. One is wind. The wind pushes the surface of the ocean, creating currents. And the second one is the Earth's rotation. It causes currents to curve. The northern hemisphere curves to the right, while the southern hemisphere curves to the left. The third one is temperature and saltiness. Cold, salty water is denser and it sinks. Warm, less salty water is lighter and it rises. You can kind of think of it like ice compacting and then ice melting, or the ions going together and coming apart. Also, the shape of the continent is the last one. The land masses in the ocean. They block currents and redirect them, shaping their paths. How ocean currents influence climate? It's quite simple. Warm currents equals warmer coastal climates. Cold currents equals cool, dry coastal climates. This picture right here is a diagram of the global conveyor belts. It shows the warm and the cool currents moving throughout.
Mountains have a big impact on climate because of their elevation and how they interact with air movement. And these images are mountains that exemplify this. So, as you go higher up in the atmosphere, temperatures drop because of air is thinner and holds less heat. Mountains also block winds and clouds. On the side facing the wind, the upwind side, air rises, cools, and releases moisture, making it wet and cooler. On the opposite side, which is called the downwind side, air becomes dry, creating what's called a rain shadow. With the climate change, these temperatures and rainfall patterns are shifting, which can affect water sources and ecosystems that depend on mountain climates.
Curvature. Due to the Earth's curvature, the sunlight is distributed unevenly due to the Earth's curvature, being hottest at the equator and getting cooler once you get to both poles.
Now with tilting axis, as you know, the Earth revolves around the sun, and as it does, it spins. But the Earth doesn't spin perfectly up and down. It actually spins at around a 23.5 degree angle, either leaning towards the sun or away from the sun. If you're leaning closer to the sun, you are experiencing warmer climates. If you're going away from the sun, you're experiencing cooler climates.
Digging a little bit deeper into the tilting axis, basically, if the axis is tilted 23.5 degrees towards the northern hemisphere, that will create seasons of spring and summer, while the southern hemisphere is fall and winter. and you'll basically have the same in reverse if the axis is tilted 23.5 degrees towards the southern hemisphere. You'll also have different biological impacts, whether through plants or animals, such as hibernation, whether or not trees or other forms of plants bloom or go through withering phases within their cycle. And this basically sums up seasonality. Basically, depending on what season it's going through, how much sunlight or what hemisphere is tilted towards whatever axis is going to affect how plants and animals and basically society blooms within that time period. And basically that sums up climate change within 3 major points, which is air and ocean circulation / currents, as well as mountains influencing the airflow overall within land masses, and finally the tilt and axis, as well as the curvature affecting overall shared sunlight going throughout different hemispheres throughout the world. Thank you for your time.